Hey everyone, welcome to our very first video in the reactions of chapter 19. Okay, so this chapter is all about amines, all right? A lot of the stuff in this chapter we can't talk about because we don't know anything about aromatic compounds, but there's a few things that we can talk about, so we will discuss those. I'm going to condense like half the chapter into this one video. Okay, so I'm going to try and go through this as quickly as I can, but I want to make sure that we've got everything. So this is basically going to be split up into two parts. This first video is going to be about amines as nucleophiles, and then the other video is going to be about amines as synthesis of primary amines. Sorry. So amines as nucleophiles and synthesis of amines. Those are the two things that we're going to be talking about. So I believe in this video we have like 5 different things that we need to talk about. Or no, just 3. Sorry, just 3. Next video is 5. Okay, so like I said, we're going to talk about amines as nucleophiles. Okay, so amines as nucleophiles. So first, let's take a look at amines whenever it comes to alkyl halides. Okay, so amines with alkyl halides. So let's take this amine, this primary amine here, and then we'll react it with CH3I. Okay. And then what that gives us is this amine with 2 hydrogens on it. And it also has a Cl, or a CH3, excuse me. And this has a plus charge, so then this I minus is going to be here as a counter ion. So I've now made this quaternary ammonium salt, right? So I've added a methyl group to this N, and then I have made this salt here. So if I have excess of this amine, then another amine can come in and it can deprotonate this, and then that'll give me a regular amine. So or a secondary amine rather. So let's take a look at that. So if I have what I just had up there, right? So now this has 2 H's on it and a methyl group with a plus. So if I have another amine just floating around, right? These are good bases, right? Amines are good bases. So it can take a hydrogen off. And then what is that? If I take that proton away, then that is just going to give me this amine, right? So I form this amine, and then I also get this other salt here. And then the I minus is with this one, right? So I can do this. And then the thing is that now I have another lone pair here. So it can actually do this again, right? So I can add another methyl group onto this if I have a ton of this CH3I, right? So if I have a bunch of excess CH3I, I can add another one of these on here, okay? So what I'm trying to say is that we can have further reactions. So if I take this, if I take this amine and then put in excess CH3I, right? Then what I'm going to get, as long as I have something in there to take off the hydrogens, I add 3 methyl groups to this. Okay, so this is exhaustive alkylation, right? So this is one way that I can get this, and then there's also going to be an I minus here as well, right? I minus counter ion. So, but with alkyl halides, right, it just does SN2, right? It just does SN2. That's all that we're doing here. So we're taking this, it's coming in here and attacking there, and then the iodine is leaving, right? That's the mechanism for this, very short and simple. And then I get that quaternary ammonium salt, but it can get deprotonated by another amine, and then I can do the reaction again, you know? So like I said, this here can attack another methyl iodide, right? And then so on and so on until I exhaustively alkylate the amine, okay? So this is one way that amines can work, right? So they can act in this fashion, okay? And, there's other things that we can do as well. If I take some other amine, like, just do one more example here. If I take some amine like this, right, and then react it with this, then what I get is, oh, whoops. So what I get is this, and then I would have to deprotonate this in order to actually get I keep drawing it without the N, sorry. I'm so used to drawing it without the N. So in order to get this, I would have to deprotonate this amine here. So I'd have to have another amine come in and deprotonate it to give me that, right? So that's one example, okay? So this is one way that amines can act as nucleophiles, right? So we can use alkyl halides. The other thing that we can use is we can use ketones and aldehydes. Okay, so if we use ketones and aldehydes with these amines, then there's three different things we can use with amines, or with ketones and aldehydes. So if I take a ketone like acetone and I combine it with just a regular amine, all right, so we're just going to combine it with ammonia in this case. And then I use acid catalysis, so H plus, right? And this is basically just going to go through a condensation reaction. Mechanistically, we don't need to worry about it, but this can go forward or backwards. But all that's going to happen is I'm going to take a hydrogen, or I'm going to take two hydrogens off of this, and then add it to the to where the O is. So what that looks like is I get an N here with an H on it. So I remove two hydrogens, okay? And then whatever's left is on there, okay? So now this, there's a name for this, okay? This is a imine, okay? This is an imine. Additionally, I could also take this same ketone and do a condensation reaction with CH3NH2, again under acid catalysis. In this case, we replace the O with an N, and then I don't have a hydrogen on there anymore, I have a methyl group. This is also an imine. So an imine is a double bonded N to a carbon that either has another carbon attached to it or a hydrogen. So if I have a carbon or a hydrogen, it's known as an imine, okay? So there's two other things that we need to know. So let's take, in this case, an aldehyde. And we're going to react it with this. So NH2OH. So if I react it with hydroxylamine, then again, I get N here, but I get OH. So N and OH. And this is known as a oxime, okay? So if this group coming off is an OH, it is an oxime. And then there's one other thing that I can make here. So let's take this ketone and react it with this. So NH2NH2, which is known as a hydrazone or a hydrazine. This is hydrazine. Sorry, that's hydrazine. What I make is hydrazone. Is a hydrazone. So this is a hydrazone. So I have imines, oximes, and hydrazones. Okay, that's whenever I react hydrazine with this. The other thing to mention is that this NH2, NH2, I could also have like carbons coming off of this second hydrogen. It's just the hydrazone is where I have two nitrogens connected to each other like this. Okay, so that's what I mean by hydrazone. Okay, so that's my hydrazone group. Okay, so this is amines with ketones and alcohols. And now I'm going to have to erase this, get some more room here. Or ketones, I said ketones and alcohols, but ketones and aldehydes. There's one other thing that this can act as a nucleophile with. And that is acid chlorides. Okay, so this is acylation of amines. All right. So if I take an acid chloride, so let's say I take an acid chloride like this one, and I react it with some amine, right? So let's react it with this amine. And I usually use pyridine. Then all that happens is the Cl is going to get replaced by my amine. So I make an amide. So this is what I make, okay? And mechanism-wise, let's take a look at the mechanism. So what happens is the acid chloride is very reactive. And this amine is a good nucleophile. So this amine can come up and attack that there, right? And then those electrons are going to go onto there. So then this gives me my intermediate. This is my intermediate. This is going to reform the carbonyl and the chlorine leaves, right? We've seen this before, right? We've seen this before. So then I get this, and then my N here has two hydrogens on it. It's positively charged. Okay. And the chlorine is going to be here as a counter ion, right? So Cl minus is going to be a counter ion here. So I've made a salt. And then after this, pyridine is going to come in, okay? And pyridine is just a good base. So pyridine is going to take a hydrogen off of there, okay? And then once pyridine takes that hydrogen off, then I'm done. And then I get a protonated, I get a pyridinium. Okay, so this is what I get here. And then we also have a lump here that I didn't draw. All right, so three things that I can do, right? I can react a amine with a alkyl halide. I can react amines with ketones and aldehydes to either get an imine, an oxime, or a hydrazone, depending on what I use. And then I can also react amines with acid chlorides, and acid chlorides will always make amides whenever they are reacted with amines. Okay, so the amine is going to add once and then just replace the chlorine. Okay, and then as we said, this is the mechanism for the addition of that amine to an acid chloride. So that's it for amines as nucleophiles. Hopefully this video was helpful. In the next one, we're going to talk about how we make primary amines. Okay, so that's going to be what we're focused on in the next video. So hopefully I'll see you for that one. Have a good one.